So we continue now with the presentation from JA Solar. So we're happy to have with us Djamel Eddine Mansour, who is a technical pre-sales project manager at JA, and he will let us know about the key milestone JA Solar has achieved in TOPCon. Djamel, the floor is yours.
Hello, everyone. Thank you, Michael, for the nice introduction. Let me share my screen quickly. Please confirm if you see it in full screen mode, presentation mode, right?
All good.
Yes, perfect. So welcome everyone to this presentation on key milestones in TOPCon development at JA Solar. And get started. Yes. So today this presentation is divided into three parts. Basically, first I will be covering how JA is optimizing high efficiency cell design. Then we'll move on to the module level enhancement. And of course, finally, we will explore how better testing and analyzing can further boost the efficiency. Starting with the first part for high efficiency at the cell level. Basically, let's start with the milestones and how JA is leading the entire TOPCon era, where it has been ahead in this technology and solutions, owning the patent for TOPCon solution. Here is when the mass production started back in 2022 with around 25% efficiency. Over the last 2 years forward to today, we have there have been continuous improvement on the cell, pushing its efficiency to 26.8%. This is, of course, the mass production level. What is even more exciting is that this doesn't actually yet include the newest innovations like edge passivation or the zero busbar solutions, which I will cover more in details in the next slides. And now let's take a look at the first example on the pathway to high efficiency TOPCon cells, which is the trends in laser firing technology, also known as LiCo. As you know already, this technology focuses on boosting the cell voltage by using low corrosion silver paste and low temperature sintering. Basically, how it works is by integrating laser, we can improve the silver paste contact, which adds 0.2 to 0.4% to cell efficiency and boost the module by 5 to 10 watt. Of course, there are challenges like developing the low temperature and high tensile grid paste for the thermomechanical stability, and also ensuring a precise contact of the laser process to achieve a better performance, which is quite trivial. And next is let's look at the trends in the half cell edge passivation, another key area to improve JA cell efficiency, where we know, unlike heterojunction technology, where the cell is cut before passivation, with the TOPCon process, it's the other way around. That means we first complete the passivation and then cut the cell in half. And due to this cutting, the laser cutting, actually, we can have a efficiency loss over 0.2%, but we can, let's say, minimize this loss through effective edge passivation after cutting. And the solution for JA is to use aluminum oxide film, which help us to reduce the interface combination and then passivate the surface to keep minority carriers at bay. The deposition method here used is the ILD, the atomic layer deposition growth to achieve optimal performance. If you can see here, we have two microscope images before the treatment and after this passivation at the edge surface, where we can see clearly it becomes clean and smooth enough. And due to that, actually, we will have a gain at the cell level of more than 0.19% cell efficiency, and for the module more than 6 watts. Basically, the edge passivation is a game changer for tackling this laser cut loss or to recover from it, and to push the efficiency even higher. Now for the module level design optimization, actually to improve the module efficiency at the module level, it is important to understand factors behind the cell to module CTM power loss. When moving, for example, from cell to modules, this is a simulation created at Fraunhofer ISA where it gives us a clear picture where you can see the optical gains in green and the losses in orange, which include actually geometrical, optical, and electrical losses factors. And along with the thermal dissipation and the mechanical stresses, what GA is trying to do here basically is to, by addressing these three losses or factors, it's making a big step towards boosting overall module performance. If we take a look at the first one among these three losses, which is the geometrical loss, this is related to the size of the wafer. As you know, there has been this shift towards upgrading to larger cell sizes, which is impacting basically the module sizes then. And it's also includes changes in the cell gaps, which plays an important role here also in the module design and how everything fits together. And basically, by considering all this improvement and upgrades, the module power output showed significant enhancement, especially in the last years. As you can see, this drop of the power output. In the case of GA, they started producing the M10R, this 182 millimeter rectangular wafer last year. And by cutting it symmetrically or asymmetrically, you can actually create a larger combination of high efficiency modules. As you can see here, different modules depending on all different categories. And it has quickly become a mainstream choice across this industry, as this innovation has been a key driver in upgrading JA's module power output, where this Deep Blue 4.0 Pro has achieved an impressive maximum power of 650 watt. Actually, of course, we are also producing 700 plus watt, but this is where we use the wafer of the G12 wafer, the bigger one. Here is mainly the focus on this M10R wafer. Here is another factor at the metallization level, where the number of busbar has increased significantly, going through multi-busbar last year. This year, the small multi-busbars, until going back to 0 busbars with a 20% silver paste saving using the grid layout and ultra-fine round wire ribbons, by using electrical conductive adhesive, but also soldering is also considered at GA, for example, which will bring me to the next slide with the 0 busbar topic. Basically, if we look at now the 0 busbar from the optical perspective, optical loss perspective, now busbar means less shading area of 5 to 25%. This is actually, this leads to a higher light absorption rate. And by improving this optical loss, the incidence effect, or let's call it the IAM loss, is reduced, and the module power output is enhanced by 3 to 5 watt, and the higher efficiency to a higher energy generation. Now, furthermore, basically, when we look at the electrical loss, the use of this thin wire plays a big role. They basically allow for a shorter current transmission rate, which helps to reduce the serial resistance from both right and left side. And actually, this help us to lower the resistance loss to have even a greater power output. In terms of quality, the 0 busbar technology can minimize power loss that is created by micro cracks, and this is due to the lower welding temperature and small localized stress, as you have then more contact between the wires and the fingers, and which is ensuring durability and the long-term reliability of the PV module. As a global leader in solar product manufacturing, JA is, let's say, is taking on responsibility of driving industry towards more sustainable practices. With the zero busbar high efficiency module solution, we have achieved a 5% reduction in carbon emissions by optimizing auxiliary materials such as the silver paste or welding wire films and so on. On the manufacturing side, we have implemented advanced welding technology by lowering the welding temperature by 15 to 40%. These innovations reduce reliance on natural resources, but also enhance production efficiency and significantly cut energy consumptions at carbon emissions. Also, in terms of aesthetic, it's getting better in terms of the appearance of the module for the next generation. Here is the last part where, let's say, to emphasize the importance of characterization in detecting defects and then tracing them back to production to achieve a higher efficiency. And when comparing conventional with the modern characterization, before it was more about measuring the IV curves, electroluminescence insulation tests, and so on. Plus the basic degradation following the standardized testing. Today is more adding this AI-driven and machine learning data tools to which are implemented in some techniques for a more accuracy and quick tests. Also, in-field high power with best levelized costs of energy, which I will give you a real example in the next slide about this one. A new application and integration where GIA is leading, such as self-cleaning solution on the frame or the anti-glare coating on the glass for safety. Marine applications such as ocean blue module for floating PV, and in-depth, the next one is the in-depth reliability by going beyond the standard and extending more duration and cycles of the test. It has always been JA philosophy to ensure that the module is robust and stable enough. Last but not least is the, as I said before, the ESG topic with the low carbon footprint in manufacturing, especially in our better traceability at JA vertical integrated manufacturing, but also to ensure better life cycle analysis. To wrap up with this last slide, basically here is a real example of customer value analysis in the field in different projects using the GEM 72D42LB large modules, which have actually outperformed, let's say, the expectation in different environments, whether it is in extreme cold, hot and humid, the tropical one, or offshore applications and locations. In the chart here, the blue bars shows the expected power generation and the yellow the actual performance. As you can see, in the most cases, basically the module are generating 8 to 10% more power than expected across all 3 different climatic zones. And this is really demonstrating the reliability and the strength of this Deep Blue 4.0 Pro in the real world conditions. With that, I would like to thank you for your attention, and please reach out in any questions.
Thanks, Djamel. Great overview. We are right in time, actually, but since you are on the panel, I would ask you if there's any questions in the chat to take it from there. Otherwise, I keep mine for our discussion at the end of the event. Okay, thanks again, Djamel.